And welcome everybody to the Daily Space Weather. We are looking at the sun here in some composite imagery from the Solar Dynamics Observatory. It's ultraviolet light in 171 angstroms wavelength, as well as the colorized magnetogram. Noting two new sunspot groups. Sunspot 2827, seen here, already beta class, increasing the likelihood for additional solar flares. Sunspot 2828 has also grown in the past 24 hours. Also an ongoing coronal mass ejection situation, some ejecta on the way to Earth for a likely glancing blow, and more. Here's another composite image. This is three different wavelengths of UV light, 335, 193, and 94 angstroms. And we'll also show you the colorized magnetogram alone. And you can see the formation of those two new sunspot groups. Colorized magnetogram is probably the easiest way to find sunspots at a glance. Sunspot 2827 is significant already. And likely sunspot 2828, a little bit less so. Continuing on, let's take a look at the viewpoint from Lagrangian point 5 as there is an ongoing coronal mass ejection situation, a very slow coronal mass ejection is still in the process of unfolding here. So for you new viewers out there, Earth would be out in this direction from the perspective of stereo A. Again, here's Lagrangian point 5. That's the gravitational equilibrium point at which stereo A orbits. You can see this ongoing coronal mass ejection here. That is going to continue to eject until it ejects. And here's also the viewpoint from Lagrangian point 1. This is the LASCO SOHO C3. And initial indications are that this coronal mass ejection we're watching here is headed to the southwest of Earth. You can see it just starting to protrude there from behind the coronagraph obscuration disk. And so we'll be keeping an eye on that as that continues to erupt. Again, here's back to stereo A's perspective at Lagrangian point 5. This will also affect the heliospheric current sheet polarity, folks. Once this ejecta finally gets through ejecting, it's likelihood that the Earth will snap rather suddenly into the South Pole-oriented current sheet. We'll show you that momentarily. First, a diagram of the solar system. And we've advanced that 1 week to June 6th. Here's a star chart. If you're up before dawn, you may see the Moon and Saturn and Jupiter. And trailing the Sun, we've got Venus and Mercury. So 4 planets, 1 star, and the Moon all up there at the same time from my location in Lehigh Valley, Pennsylvania. The 10.7 centimeter radio flux has dropped back down to 76. Here's a 1-year chart of that. It's this black line. And you can find that graph yourself. Don't take my word for it. Check solon.info/solar. Solon.info/solar is where you can find that. The red line down there is the sunspot number. And NOAA is forecasting some geomagnetic unrest from the coronal mass ejection we covered in great depth yesterday. Expecting that to strike late in the day on June 1st. I would say late in the day on May 31st, early in the day June 1st, as I think it was a little more fast-moving than NOAA seems to think. And some of the protons from that coronal mass ejection have already arrived. It's this proton spike you see right here. There was a brief period of solar storm as a result of that relativistic series of protons striking the magnetosphere. Let's look at seismicity here real quick. Here's the 90 days of seismicity bar graph from volcanodiscovery.com. And here's their sort by magnitude screen. Only a couple of earthquakes over a 5 magnitude here in the past 24. One near Oceania there, around Tonga and Fiji, and one near Japan. Let's check USGS's list. So there were a couple deep quakes also, such as this 4.4 at El Salvador. I'm just going to scroll up the list here. If there's anything we leave out, please leave us a comment and let us know. Also, Argentina saw a deep quake. Make it 2. Very close to the same location there. And only 6 minutes apart. So, 2 deep quakes there. Also, Oregon saw a 3.2. Fiji saw a 5.3. There's the one of the 2 5 magnitude quakes. Well, also, China saw a 5.1. By the way, that Fijian quake was at 530 kilometers depth. A little bit deeper than humans have ever drilled into the Earth. And next, looking at volcanoes, here's some satellite imagery with some overlays about Nyiragongo. So it looks like it's been calming down a bit there, although tensions are still high in Congo, the city of Goma, very close to Mount Nyiragongo. And the yellow outlines there are the lava flow locations. So things have calmed down, but there is still a little bit of seismicity going on there. And that's the only volcano on the list so far today for May 30th. It's a great reminder to not pole vault the caldera. Please don't pole vault the caldera. More on the Redbubble shop a little bit later. There's a sale going on the whole store. You can find links at smAsho.com. First, some more data like the sun-facing suite of instruments on the GO 16. No major flares since this C9.4 flare that sent coronal mass ejection Earth's way. Although we do see background levels here in the B-class range. Increased X-ray outputs from the closest star. So here you can see this proton event, and there still are some slightly elevated levels of protons in the greater than or equal to 10 mega electron volt range. That's the 3-day chart of the GOES proton flux. We do see an anomalous dip here in the GOES magnetometer. Not exactly sure what that's all about, but in any case, that's the 3-day chart of the GOES magnetometer. And we're seeing very high lows right here and a very tight range of the magnetometer over the past 3 days, as you can see there. And here's what we're talking about earlier with the heliospheric current sheet. There is some plasma out in this area, and it is in the process of ejecting right now. There is a South Pole oriented current sheet coming. So here's this, you see this red area there, the South Pole oriented current sheet. Having just made it to stereo A there, keep in mind the magnetic environment can suddenly change, and this data was 1 hour and 14 minutes old when we made the video. Here's the last image. And Earth may be a little closer to the South Pole current sheet than is evident on that data. So here's the line of sight view of that same data set. And the blue line gives us insight into which field is dominant. For example, you can see the North Pole oriented, the North Solar Polar Field is currently dominant, as the blue line is south of the equator, indicating more magnetism from the North Pole. And here's a line of sight coronal hole plot. It shows you the sun's B field in blue. And the sun has been extremely coronal hole deficient throughout cycle 25. So we're seeing a surprising shortage of coronal holes. Anyway, there's the data on that. Here's also detected filaments and detected sunspot groups. So you can see 2827 is already named on the detected sunspot groups imagery here, and sunspot 2828 not yet named. And again, once that coronal mass ejection is done releasing, we may see a sudden snap across into the South Pole current sheet. And that could spark some geomagnetic unrest and so on, as we expect to see some sudden impulses on the GOES magnetometer data. Global geomagnetism currently only at a KP of 1. And let's take a look at the real-time solar wind. So here's a real-time solar wind over the past 24 hours. Saw some spikes here. This looks like a weak coronal mass ejection strike, as we see the density and the density and the speed coming up at the same time. Also accompanied by a shift in the phi angle and the BTBZ. Anyway, nothing too crazy happening there in the past 24 hours on the real-time solar wind. Current solar wind density around 7.5 protons per cubic centimeter. Solar wind speed 474 kilometers per second. Next 4 hours of geospace magnetosphere movie. You're looking at nanopascals. It's the space weather modeling framework. It is a model based on a whole bunch of data. Everything from GOES electron flux to solar wind data and a lot more. And the scale you're seeing here is in nanopascals. It's only showing you 0 to 1.5 nanopascals, which is magnetohydrodynamic pressure, and fairly stable here over the past 4 hours. Here's 4 hours of ground magnetic perturbations, changes to Earth's own B field, otherwise known as geospace delta B. And since there is a geomagnetic excursion going on, we look at this daily. Earth has 2 north poles, one over Canada, one over Siberia. And the South Pole has left the Antarctic continent, thousands of miles from the geographic South Pole. Someplace south of Australia is where the South Geomagnetic Pole is currently located. Today's cosmology segment is postponed. However, check out the additional videos in our playlists, youtube.com/smashamash/playlists. There are nearly 200 cosmology segments in there. Check them out. Again, youtube.com/smashamash/playlists. We're also on Twitch, twitch.tv/smashamash. Thanks to our YouTube subscribers. And don't forget to tell your friends, foes, science noobs, and science pros about the channel. We'll be streaming live to YouTube at the moment of the solstice, which is on June 20th at 11:32 p.m. and 9 seconds. So make sure you join us for that. Also, did you see our smashamash.org presents the sun video yesterday, featuring some close-ups of the flaring and coronal mass ejection? Again, you can find that playlist as well at youtube.com/smashamash/playlists. We're also on Instagram. Thanks to our followers there. Thanks to our followers on Twitch. And shout out to David Birch. Thanks for noticing. Also, our Redbubble shop is featuring a sale, 20 to 60% off of everything site-wide with the promo code FINDYOURTHING. So to find your thing, head to smashamash.com, click on SMASHO merch, and you'll find the Smash Team shop there. We've got 7 designs. And again, massive savings here through June 1st. So up until June 1st, rather. with the promo code FINDYOURTHING. Little weekend sale going there on at the Redbubble shop. And I figured I would put up the astronomy picture of the day from apod.nasa.gov. apod.nasa.gov. And this image is showing you some auroras and lenticular clouds here over Iceland. A great example of the altitude differences between clouds and auroras, which can reach all the way down to about 100 kilometers. Clouds are more like ending around 10 kilometers of altitude. And this giving you a great visual insight into how much higher up in the sky the auroras are compared to the clouds. And you can look at it yourself at apod.nasa.gov. Next, we'll talk about electron flux. As the electrons out there in Earth's geospace are able to do things like charge up satellites. Let's see if it's going on now. Nope, no charging of satellites right now. To comment on, here's a one-year chart of the electron flux over the past year. We're at quite low levels here. And there is the GOES electron flux over the past 3 days. Nothing to write home about there. Forecast is for relatively flat levels here over the next 3 days. I would tend to agree with that forecast, which is the green boxes you see there on the screen. And here's the total electron content forecast. This will show you the likelihood of GPS errors in your location. Most of those occur around the equator at noon, however. Sometimes we see anomalies, and that's part of the reason why we look at the data. I'll let it play through a second time here. And this is showing you the electron density for the full air column, all the way up to the location of a GPS satellite at tens of thousands of miles of altitude down to your handset. Here's another diagram of the atmosphere because we're going to show you the F ionosphere next. It's that red F around 300 kilometers. And here is the F ionosphere animation. Please wait. I assure you we had that animated when I did show prep. And we'll let this play through as well. What you're seeing here is 2 days of data. And this website is provided by Australian Government Bureau of Meteorology. And I'll stop it at the latest image here in just a minute. Here's a latest image from 10:45 Universal Time. Things looking relatively normal there. Next, we're going to do a meteorology segment. And today's meteorology segment will be integrated into the daily space weather. Here are the surface winds of the Western world. Let's take a look at the jet streams. The most significant global snapshot of weather. Chaotic jet streams here over the Northern Hemisphere especially. They are all over the place. Highly incoherent jet stream in the Northern Hemisphere. A little bit more coherent in the Southern Hemisphere. How about the Eastern world? There you have it. Quite chaotic jet streams to say the least. Currently on planet Earth. Here are the surface winds of the east. And we see a powerful anticyclone here now in the southern Indian Ocean. That counterclockwise rotation, likely associated with high pressure. Continuing on, to check out a real-time lightning map. I like to use lightningmaps.org, and today we're seeing some terrestrial lightning west of Amarillo. Hey, Tucumcari, there's lightning to your north. Anyway, here's the zoom out to the global lightning map. Here's the NASA GOES lightning mapper. Quite a bit of lightning here off of the southeast coast of the U.S. A little bit on North Carolina as well. And some lightning moving into southwestern Texas. Here's where pressure cells are now. We're going to advance this into the Euro forecast. Here's the European forecast for pressure at 12 noon Eastern Daylight Time tomorrow. Powerful anticyclone here off of Newfoundland. This high pressure cell here will be in charge of the North Atlantic for the coming day or so. U.S. Doppler radar map is next. NASA GOES shortwave radiation map to show you clouds when it's too dark to see them with a visible satellite. And here's the water vapor map. Stagnating moisture here over the Oklahoma Panhandle, Kansas, Nebraska, and western Iowa. Some heavy moisture here moving into extreme western Texas. Again, here's the 3.9 nanometer radiation map and the U.S. Doppler. And back to the water vapor. Hope that gives you any insight. Here come bonus features for the Daily Space Weather video. We're going to look at Udaipur, India's hydrogen alpha imagery. It was only 3 minutes and 32 seconds old when we made the video. Again, there are filament eruptions occurring as we speak. And it may cause some shifts in the magnetic environment. At least the sensing of the magnetic environment. Anyway, there's that. Here come additional bonus features. The high-resolution intensitygram. Sunspot 2828 and Sunspot 2827. 2828 looks like it's already beta class as well. And indeed, we're seeing some opposite polarity umbrae there. So we've got south and north pole umbrae. Sunspot 2828 is beta class. So is Sunspot 2827. There are the fields with that. And 2827 looking like it's forming into a ring shape here. Again, don't forget to press like and subscribe if you're viewing the content on YouTube. Thanks, viewers. Don't forget to press that share button. Leave us a comment. Tell your friends and foes about the videos. Also, thanks to our patrons, the main source of funding for the content. And if you'd like all kinds of early alerts, insights, backroom information, and multimedia like music, ringtones, all kinds of custom graphics and so on, consider becoming a patron at patreon.com/smAshomash. Again, thanks to our patrons. Cheers. Patrons listed in order of total lifetime contribution. And our bonus features have two more animated views of the closest star here. It's the 1700 angstroms view from the Solar Dynamics Observatory. Can see the setting of Sunspot 2824 as well as the formation of Sunspot 2827 and Sunspot 2828. You can also see some evidence of filaments up here in the northern hemisphere. And last but not least, 171 angstroms. And once again, thanks for tuning in to the Daily Space Weather. May that solar wind be at your back.